For modeling the teapot, we use a curve. In the outliner, we activate the Scene collection. Right-click, choose New Collection and rename it Teapot. In the 3D view, press Shift-A and select Curve, then Bézier. Type S0.1 to scale the curve. Press the key combination RX90, followed by Enter to rotate the curve 90 degrees on the X-axis. Next, press RY90 followed by Enter to also rotate the curve 90 degrees on the Y-axis. In Edit mode, we start modeling from the body of the teapot. If you remember well in the previous lesson, when we scaled the reference photo, we changed the position of the pivot point by setting it to 3D cursor. Therefore, before starting to model the curve, press the period key on the keyboard and reset the pivot point position to bounding box center. Now, using extrusion, scaling, rotation, and adding new vertices, let's try to follow the shape of the teapot as closely as possible, also creating the thickness of the body. During any type of modeling, whether polygonal or with curves, it is essential to keep the number of vertices as low as possible. This principle becomes even more important when working with curves, as we are doing now. Instead of adding many control points, we can shape the profile by manipulating the handles of each existing vertex. Taking this minimalist approach offers significant advantages for the workflow. With fewer vertices, we'll have fewer elements to manage. This allows us to focus on the overall shape rather than getting lost in the details. A curve with just a few but strategically placed points is much easier to modify precisely because it's cleaner, and it also naturally looks more harmonious. The handles of Bézier curves are incredibly powerful tools for this very reason. They allow you to sculpt smooth and precise curves without having to add more points. Watch closely as I move these handles. It's like adjusting the tension of a rubber band. The more you pull the handle, the more the curve stretches in that direction, creating a wider and smoother arc. Blender provides us with different types of handles for each control point. Aligned, the ones I'm using right now, automatic, which let us standardize the distance of the handles from their central vertex, vector, perfect for creating sharp and precise angles, and free, which give us maximum control for more complex situations. In short, each type has a very specific purpose. For this teapot profile, I'm using aligned handles, which ensure smooth transitions in most of the shape. But they're also great when I need more refined control near changes in direction. This stage of modeling the profile that you're watching is really crucial because it defines the silhouette of the final object. So always take all the time you need to carefully perfect the profile curve. The geometry we'll create at the end of this process could also have been achieved through traditional polygonal modeling. I chose to proceed with curves to show you how Blender is still flexible and can work with this kind of technique, which gives us greater precision in certain situations. At the same time, I wanted to show you how easy it is to later go from a profile curve to generating a complete polygonal shape. Once this modeling phase is finished, let's return to Object Mode and save the file incrementally. Now that we have the Teapot's profile, press Shift-D followed by Enter to make a copy of it. In the outliner, let's create a new collection and name it Backup. Right-click on this collection and assign it a color tag to highlight it. Now drag the curve we just copied into it and then rename it to Teapot Body Curve. Disable the backup collection. With the curve selected, go to the Properties window and open the tab related to curves. Change the resolution preview parameter to 8. This way the number of vertices will decrease, as will the precision of the curve. But the model will become easier to manage. In the 3D view, right-click and select Convert to Mesh. Switch the working mode to Edit mode and further reduce the number of vertices in the mesh, keeping only those essential for generating the model. During this phase, remove unnecessary vertices using the Dissolve Vertices command. After converting our curve into a mesh, we might still end up with unnecessary vertices that do not significantly contribute to defining the shape. At this point, it becomes important to know how to further reduce these vertices while maintaining the integrity of the mesh. If you paid close attention, you will have noticed that I made sure to keep 5 vertices at the junction where the spout connects to the container. I placed 2 of these, one on the upper part and one on the lower part, and kept 3 more vertices between them. This precaution allows us to have the right number of faces needed for modeling the spout and the handle of the teapot, which we will do later. As you can see right now, to remove unnecessary vertices, we use the Dissolve Vertices command instead of Delete Vertices. This distinction is fundamental. While Delete Vertices completely removes the vertex, creating a discontinuity in the mesh, Dissolve Vertices removes the vertex while maintaining the connection between adjacent vertices. In other words, Dissolve Vertices merges the selected vertex with its neighbors, preserving the overall topology of the mesh. This approach is usually used, for example, when we have a series of aligned vertices. Thank you. That define a straight segment. In these cases, we can reduce the number of intermediate vertices to a minimum, keeping only those at the ends and at points where the curvature changes significantly. During this optimization process, it is important to continuously assess the visual impact of our changes. The goal is not simply to reduce the number of vertices, but to do so intelligently, while preserving the essence of the original shape with the minimum amount of necessary geometric data. Let's switch to the top view. We select all the vertices and in the tool shelf click on the spin icon. A blue indicator appears in the 3D view, allowing us to rotate the teapot's profile around the 3D cursor. Click and hold the left mouse button on the right plus sign, then move the mouse to extrude the profile in a circular fashion. Hold down the Control key to rotate in 5-degree increments and stop when you reach the starting sector. Open the window for the spin command, which is located in the bottom left corner, and set the steps parameter to 32 to increase the mesh's precision. Select all the vertices, press the M key and choose the by distance option. This way we eliminate all overlapping vertices. Let's go back to object mode and set the view to solid. Press Ctrl-A and from the menu that appears, choose Rotation and Scale to apply both rotation and scaling to the model. To refine the shape of the container and make it more uniform, press the Ctrl-2 shortcut. This applies the subdivision modifier to the geometry. In the 3D view, right-click and select Shade Smooth to further smooth the model. Let's go to the front view to refine the shape of the container. Switch to Edit mode and adjust the position of the vertices distributed along the model by appropriately selecting the loop cuts using the Alt and left mouse button combination. Since we've applied the subdivision modifier, the cage that encloses the container model is slightly offset from the mesh. To have greater control and precision over the changes we'll make, we can activate the on-cage icon found in the modifier panel. During this phase, we can add more loop cuts where necessary. With this final modeling phase of the container, we define those parts that still don't match the reference photo, such as the base and the top opening. Therefore, we can modify or add additional loop cuts where necessary to more effectively adapt the geometry of our mesh, especially in areas where greater definition is needed to match the reference image. As I pointed out earlier, when we redistributed the vertices before performing the revolution of the mesh, I placed 5 vertices at the point where the spout attaches to the container. Now, this precaution is clearly highlighted by the 4 bands of polygons that have been created, which will later allow us to model both the spout and the handle of the teapot more accurately. By using the on-cage visualization, we can more accurately assess the changes we make to the geometry, especially regarding the upper opening. This visualization mode allows us to clearly see the mesh's lattice structure, making it easier to identify areas that require further adjustments and ensuring we have more precise control over every aspect of the topology. At this stage, it is also essential to pay attention to the even distribution of the polygons. A well-constructed mesh features a balanced polygon density, with higher concentrations only in areas that require more detail. The ring selection function allows us to select and modify entire sequences of vertices at once, maintaining the symmetry and regularity of the structure. The strategic addition of loop cuts around the base allows us to precisely shape the curvature and width of the support. Similarly, by working on the upper part of the container, we can more carefully define the profile of the opening. As you may have noticed, in modeling this object, we went from generating a simple curve to shaping it to converting it into a mesh, and now to fully refining the latter. This gradual process has allowed us to understand the different stages of creating a 3D model and to appreciate how each step contributes to the final result. The workflow we followed demonstrates Blender's great flexibility in handling various modeling techniques, allowing us to choose the approach best suited to the creative process. You saw how, even though we reduced the precision of the initial curve, we gradually added complexity and detail to our model. This incremental approach is particularly effective in 3D modeling, where it is often preferable to start with simple shapes and gradually refine them rather than trying to create complex structures right from the beginning. After making the necessary adjustments and before moving on to modeling the spout and handle, let's save the file again.